VMware allows you to run multiple virtual machines on one physical host. On occasions, you will find that you are getting a lot of value for your money because you're consolidating a lot of servers on a single host or a cluster of hosts. But sometimes you will see performance issues and performance degradation. Thankfully, VMware have got their own proprietary memory management techniques, and today we are going to deep dive into 4 techniques which VMware has for managing the memory. Hello everyone, this is Ibrahim Qureshi and welcome back to the session 12, VMware Memory Management. Let's not forget, this training is for anyone who wants to learn virtualization. There is no IT background or experience required. So be sure to subscribe to my channel and hit the notification button if you haven't done so already. And a big thank you to everyone. Today I have achieved 322 subscribers. Okay, so let's get started. The topic for today is what is VMware Memory Management. As I said, there are 4 major memory management techniques which VMware ESX host use to manage the memory on the host. We are going to discuss some benefits of the memory management, disadvantages of overcommitting host to the memory, overcommitting host memory, sorry. Okay, so the first technique, memory management technique, is transparent page sharing. We are going to deep dive in all of these, but let me just give you what they are. So the first one is transparent page sharing, TPS we call it. The second one is ballooning, VMware ballooning. The third one is memory compression. So VMware ESX host compresses the memory so that it can accommodate more data in the memory. And finally we have swapping. Okay, so let's get started. Transparent page sharing. So I have this screenshots taken from a KB article which you'll find in the reference at the end. But because this amazing article shows most of the thing which I wanted to discuss, I just thought of using it and not reinventing the wheel again. Transparent page sharing basically is sharing of memory pages which are same across across the multiple virtual machines. So we have VM1, VM2 and VM3 here. Okay, and then in this we are looking at the pages, the memory within these VMs, and you can see similar pages written here. So we have A, which is light blue, B, which is darker blue, C is a green color, and then D is light green. So if we can see, we don't have a C here, we don't have a C here, but we have A. So we can basically combine all those A and reference it. Because they are the same page, we can reference all these which are similar pages in here. So what ESX hypervisor does is it basically uses this technique to point the pages which are similar in a pattern, and then basically reference it in the host in a way that it can basically avoid using duplicate ones, and then it will only reference the same pages where it needs. So in other terms, this is how you will achieve it. So you have A, which is written like this in hexadecimal, and then D and B. So basically it will reference all the D's in one location and the A's as I discussed and B's. So originally we have how many A's? 1, 2, 3, 4, 5 A's. So we had 4 A's, 5 over here, and then we have so many B's, and then C, there's only a single C here, yeah, and then we we have 1 2 3 4 5, so quite a few D's as well. So before, the memory paging was looking like this, but now basically we have re-referenced all the A's and we have put only one pointer to A and one pointer to B, and then C we can put one pointer to C. So all these B's, wherever there is a requirement for B, it will automatically swap it with this for any of the VM. So hope it makes sense. This is called TPS or transparent page sharing. Recently there was a news and there was a KB article saying it can be this technique can be exploited because you're essentially sharing the same memory of a different machine, and if some hacker basically exploits these memory code, then you can actually find out what's happening here. More so this was worrying for people who are having what do you call the service provider model, where we have multi tenants or multiple clients running on the same infrastructure. So what VMware has done, if you do want to enable this, you can have a shared secret password for sharing the pages, and obviously if we have enabled it, the password has to be set on number of VMs which you want to share it across, and that's how they have come across fixing this issue. You can read more about it online if you want to. Let's get on to the next topic. Ballooning. Ballooning can be used when we have VMware Tools installed. So just to give you an idea what is actually VMware ballooning. Ballooning basically, again, let's complete the slide. So it can cause performance increase or decrease as the guest VM has to use its own memory techniques for swapping. So in some situations we have seen that the performance does go down. So what is ballooning? Ballooning basically means in the virtual machine, if you have VMware Tools installed, VMware has its own driver running within the guest OS. What that does is, if the host is struggling with memory, it will try and identify the VMs which are having allocated memory but they are not, it's not active. So maybe the VM is having 8 gig memory, but the active memory is only 2 gig or 3 gig. So what this ballooning driver will do is it will start expanding, it will start growing, and it will take 4 gig memory as an example. And then what it will do is it will in turn tell to the hypervisor saying that I have got the 4 gig memory now from this VM. Then the hypervisor will consume that memory and give it to any other VM which requires it. So if I want to show you quickly, let's quickly do a paint window. So this is your guest hypervisor, this is your VM, this is your VM, and we have another one. So basically what happens is, let's say if this memory, if this whole guest OS is struggling with memory, what will happen is the host basically will see whether it has the memory to give. If it doesn't, then what it will do is it will see how much memory this VM is using. If it is only using this much memory, for example, so what it will do is it will trigger the ballooning driver. The ballooning driver will acquire all these memory which is not used and give it back to the host, and the host basically will take it and give it back here. So it's called ballooning. And when the requirement is done, when this VM doesn't need it anymore, it will basically or if the host doesn't need it, it could be not just the VMs need it, it could be the host which needs more memory as well, don't forget that. So when it doesn't need it anymore, it will, as on the first occasion it has inflated the ballooning driver, then it will deflate the ballooning driver. That means it will give the memory back to the same VM which it has taken. So again, this can only work if you have the VMware tools running. So the requirement is you need to have VMware tools installed and running. So obviously you need to have it installed first, and it has to be running. Only then this can be used. Hope that makes sense. Let's get back to the presentation again. So as you can see, this is the example which basically these files can be written back, or they can be basically paged within the guest OS. Can start using the its own proprietary memory management techniques, and it can start writing to the memory to the disk if it was using it. And then what will happen is the ballooning driver will give it to the host, and then the host will use it as it needs fit. The next one we have, the third one, is memory compression. So host compresses the memory, but this has an impact as compressed memory takes longer time to get access for read and write. So this is how it happens. So this is the memory, and basically if it finds that there are bits which it can compress, it will compress those, and it will combine ENF in one memory unit. So when you need access, then it has to decompress and give it. So that's why it will take a little bit overhead if the host starts using this technique of memory management, which is compression. So you also have to remember that before it was having 2 bits, but then it has compressed it and it has gone ENF. I think memory compression will give you approximately 50% compression, and even memory page sharing sometimes can give you up to 50% of memory reclamation. Is the memory reclamation technique, TPS, which is transfer page sharing. Okay, so let's discuss about the last one, and this is the last resort as well for the ESX host, because I say this because this is not if the host start doing swapping on this physical disk, that means you're having serious performance issues already on your environment. So host swapping memory, basically this is used as a last resort, as I said, and cause serious problems. So in simple terms, you need to be mindful. If the host is swapping memory, that means you're not in a good position. Your VMs are already struggling. It has tried out all the other memory techniques which we have discussed already. That is, it has tried out the transparent page sharing, the compression, ballooning, and then now it's down to actual writing its own physical memory to the disk, which is very slow when compared to the actual memory, which is the random access memory which we have, RAM, which we have on the host. So this is why this is a sign of serious problems, and you need to look into addressing these sort of things if you're seeing these. Another quick one is, if you log into the ESX host, you can run some CLI command called ESX-stop, and that will show you some things. I'll do another demo on ESX-stop and how to log into the ESX host and check it, for checking ESX-stop and other useful bits which you can find there. So that's another demo really. So as you can see, these are the bits which memory bits which are there, and what will happen is before swapping it is like this, and then after swapping basically it will write those bits to the physical disk, from the memory to the physical disk, and then that's how swapping takes place, which is no different than how majority of the OS does, like Windows and Linux really, because Windows has a swapping mechanism which it calls page file or virtual memory in Windows terminology. So all it is doing is writing the memory from the physical RAM or the virtual RAM to the disk, which is physical disk or the virtual disk, and that's also not very good even within the guest OS if it does that. So again, this is on the host level. So if the host is struggling very badly, then it will start using this technique, which is swapping. Okay guys, so let's discuss a little bit benefits of memory management. Performance can be delivered without without VMware administrator. I forgot to write administrator here. Getting involved. Yeah, so VMware obviously is involved. VMware uses its own algorithm to manage the memory, and the techniques which we discussed today are four important techniques: TPS, transference, page sharing, um, ballooning, compression, and paging. Okay. Disadvantage of overcommitting host. So performance problem on the guest virtual machines. I have seen sometimes. I have seen in production environment we do have some environment, some cluster which are having these issues where I'll discuss what we can do to fix this in the next slide. But if you see any of the VMs struggling, by all means you need to start exploring the reasons why, which VMs are having more contentions, whether it is on memory. It could be very well be CPU as well, so you need to also look at other aspects as well. Performance, and you can also see performance problems on the ESX host as well. Solutions, as I said, as I promised, this slide will cover solution of memory for memory bottleneck. In reality, VMware does handle most of it swiftly, but it might come to a point where you have seen that there is not, the hosts are struggling. It is doing everything possible. It is using the memory management techniques, and still you're getting performance issues. In that scenario, guys, the only other resort is for you to add more memory. If there is capacity in the host, if you have free DIMM slots, then you can buy more memory. Again, obviously this is an investment you need to do because your environment is struggling. I guess you have to shred some money out from somewhere and do that. Also, if there isn't any option for increasing memory, then you need to consider adding more host to the cluster as well. If you do have obviously multiple hosts in the cluster, then you're not obviously if you do add these hosts or memory, it's good. If not, what will happen usually is if a particular VM is struggling, then let DRS take care of it. So DRS is distributed resource scheduler, take care of the workload within the VMware. So we haven't discussed this deeply, but this is another terminology, DRS, which is distributed resource scheduler. What happens is basically VMware picks up a host which is becoming very busy, and then it also knows the host which is less busy, so it moves the VM. vMotion is the terminology which we'll use. It moves the VM from the busy host to a less busy host, which is having more availability of CPU and memory. So sometimes that is the solution really, which doesn't involve you to invest money, but to do anything from your side. But it's available on certain licenses, so you need to have an enterprise level license to be having vMotion running and DRS running. It's not available on Essential. So we'll discuss this in the coming topics. These are the references for today's images which I have got. I have found some good blog like VM Guru, which has a really nice article on what we just discussed. I will put it in the description field today. And another blog I found is the is this one, the last one, Herox, blog.herox.com, that is using the same KB article which I have mentioned here. This obviously article was for ESX vSphere 5.0, but it still is valid for ESX 6.7, and hence why I have used those images for today's class. Okay, so I hope you enjoyed today's session. Don't forget to reach out to me on Twitter. You can find me at Ibrahim Qureshi, and you can find most of the stuff which I'm doing on my blog, on my videos on my blog, so you can follow it nicely you're missing out something. And the question of the day today: which memory management technique needs VM tools to be installed? So we discussed 4 memory management techniques. I'll repeat the 4. Just mention in the comments below which one needs VM tools or VMware tools. So the first one we discuss is TPS, transfer page sharing. Second one we discuss is VMware ballooning. The third one we discuss is compression, and last one is swapping. So which one requires VMware tools? Comment on below, guys, and let me know whether you remember what is the right answer. Okay, and don't forget to subscribe to my channel, as I said earlier, because I'm actively working on other ideas as well to explain you the terminology and the VMware technology itself. So don't forget to subscribe. Enjoy watching and keep sharing. Thanks.